Hello friends, Namaskar, this is Sanjay. As you are aware, the CTET December 2021 examination was held from the 16th of December of 2021 till the 21st of January of 2022 in successive batches in an online mode. And in today's video, we will solve the mathematics questions from the paper 1, which was held on the 1st of January of 2022. And in this entire series, we will be solving 23 question papers and with 30 questions per subject per paper. We will be solving 690 questions per subject. And all of these videos are available in both English and Hindi versions on our channel. So let's get started. In a school, there are 96 teachers, out of which 3 by 8 teach high school and 2 by 9th of the high school teachers are maths teachers. Then the number of high school teachers who don't teach maths are how many? So first, let us see how many are high school teachers. So if there are 96 teachers in total, then 3 by 8 of them are high school teachers. Therefore, we multiply this by 3 by 8. So we get 12 and 36 here. So 36 are high school teachers. So out of this 36, how many are maths teachers? So we have to multiply this 36 by 2 by 9 because 2 by 9 of the high school teachers are math teachers. So divided by 2 by 9. So we get 8. So 8 are maths teachers. Now we have to see how many of the teachers who teach in high school are not maths teachers. Therefore 36 minus 8 is equal to 28. So 28 are high school teachers who are not maths teachers. Therefore the correct answer is 28. 1 by 2 minus 2 by 3 minus 4 by 5 inside braces is how much? So first we will have to use the board mass rule and solve that part of the problem which is inside the braces. Therefore first let us solve 2 by 3 minus 4 by 5. So to do this we'll have to take an LCM, that is 15 here. So 3 5s are 15, so 5 2s are 10 minus 5 3s are 15, so 3 4s are 12. So we'll get minus 2 by 15. Now the problem is 1 by 2 minus 2 by 15 is equal to how much? Now if we get this number outside the braces, outside the bracket, right, there is already a minus here. Therefore this minus and this minus, they'll combine and become plus. So 1 by 2 plus 2 by 15 is equal to how much? Now again, if we take an LCM of 2 and 15, we'll get 30. So 2 15s are 30. So 15 1s are 15 plus 15 2s are 30. So 2 2s are 4. So 4 is equal to 19 by 30. So the correct answer is 19 by 30. What is the difference between the face value of the number 7 in the number 4782 and 32170? Now this question can be a little confusing because if you are in a hurry and you read this face value as place value, you will get a completely incorrect answer. But you'll have to pay attention to this. There are two different things, face value and place value. The face value of a number will always be 7, whether it is in the hundreds place or in the tens place or in the thousands place, it will always be 7. So the face value of 7 here is 7 and the face value of 7 here is also 7. So 7 minus 7 is 0. So the correct answer is 0. If you look at the place value of 7 here is 700 because it is in the hundreds place, and the place value of 7 here is 70 because it is in the tens place. So 70 is equal to, you'll get 630, and you would have got this as the answer. But pay attention to what the question is asking and then you'll be able to choose the right answer, that is 0. Which of the following statements is not true for the set of whole numbers? So there are two ways of solving this problem. First, if you remember the properties of whole numbers, that is the commutative property or the associative property, then you will be able to easily identify which of these statements is incorrect. Even if you don't remember all the properties, just substitute these values with some whole numbers, some simple whole numbers, and you'll be able to easily arrive at the correct answer. For example, if I were to put 1 and 2 here and 2 and 1 here. So 1 plus 2 is equal to 2 plus 1. Therefore, this is a correct statement. Again, 1 and 2 here and 2, 1, 1. So, 1 minus 2 is not equal to 2 minus 1. Therefore, this statement is incorrect. And we are being asked which of the statements is not true. Therefore, this is not true. And if we just continue 1 and 2 here and 2 and 1 here. So 1 into 2 is equal to 2 into 1. So this is the correct statement. And if I were to put 1, 2 and 3 here and 1, 2 and 3. So if you add 1 and 2 and then add it to 3, you will get the same result if you were to add 2 and 3 together and then add the result to 1. So this last statement is also correct. Therefore, the statement which is not true is the second one. When asked to divide a number by 6, Rani instead divided it by 9 and she got the quotient as 21 and the remainder as 3. Later she realized her mistake and she divided it by 6. So what will be the quotient and remainder if she divides the same number with 6? So first we have to find what was the number that she divided. That is, what was the dividend? Now, you know that the number here is the divisor and the number here is the dividend, and what you get here is the quotient, and at the bottom you will get the remainder. So if you multiply the divisor with the quotient and add the remainder to that number, then you will get the original number here, that is the dividend. So we know that Rani divided the number by 9. So we'll take 9 here. And what was the quotient? She got the quotient as 21. So 21 here. And what was the remainder? The remainder was 3. So 3 here. So if we multiply 9 with 21, so we will get 189. And we will add the 3 to this number, 3. So it will become 192. So this number here originally was 192. So 192, when we divide it with 9, we get the quotient as 21 and the remainder will be 3. Now Rani correctly divided the number by 6. So if we divide 192 by 6, we get 6 3s are 18 and 6 2s are 12 and 0. Therefore, the quotient is 32 and the remainder here is 0. Therefore, option 4, which says quotient is 32 and remainder is 0, is the correct answer. Which of the following is a pair of like fractions? As you are aware, the number on the top is the numerator and the number at the bottom is the denominator. So like fractions are those fractions which have the same denominator, right? So we see that in option 4, the denominator for both the fractions is 4. Therefore, here 1 by 4 and 3 by 4 are like fractions because they have the same denominator. Which of the following numbers is not a perfect cube? So we have to identify which of these numbers is not a perfect cube. Because you will frequently see questions like this about squares and cubes, it will be easy if you remember some of the basic squares and cubes, maybe from the numbers 1 to 20. So the cubes and the squares of the numbers 1 to 20. Because if you remember, then you will be able to solve this question easily. Otherwise, you will have to do a little bit of multiplication. Now, if you multiply 1 into 1 into 1, you will get 1. 2 into 2 into 2 is 8. 3 into 3 into 3 is 27. So if you multiply 10 into 10 into 10, you will get 1000. Therefore, 1000 is a perfect cube. And if you multiply 9 into 9 into 9, you will get 729. Therefore, 729 is also a perfect cube. And 6 into 6 into 6 is 216. Therefore, 216 is also a perfect cube. The cube root of 333 will come somewhere between 6 and 7. Therefore, this 333 is not a perfect cube. Therefore, the answer here is option 3. Shikha went to a brick kiln to buy some bricks. The rate for the bricks was 2500 rupees per 1000 bricks. So how many bricks can she buy if she has only 4000 rupees? So for 2500 rupees, she could buy 1000 bricks. Therefore, 2500, she could buy 1000 bricks. And for 4000 rupees, how many bricks can she buy? So for 4000 rupees, how many bricks? So this is a simple cross multiplication problem. Multiply it like this. So it will be 4000 into 1000 divided by 2500. So 0, 0, we'll cancel out the zeros, then 25 ones are 25, 4s are 40. So if we multiply 40 into 40, we'll get 1600. So with 4000 rupees, she can buy 1600 bricks. So the correct answer is option 2. Minnie told her teacher, I made a rectangle whose each side is 4 centimeter. Which of the following statements is correct? Now, if you look at a rectangle, right? So what is a rectangle? It has 4 sides and the opposite sides are parallel to each other, and it has 4 right angles. And if you look at a square, again, the opposite sides are parallel to each other. It has 4 sides and it has 4 right angles. Therefore, a square is nothing but a rectangle where all the sides are just equal to each other. That's it. Therefore, all squares are also rectangles. Therefore, the option 2, which says all squares are rectangles, is a correct statement. So option 2 is the answer here. The angles in a triangle are in the ratio 4:5:6. What will be the measure of the angles of the triangle? Now there are multiple ways of solving this problem. We can use an algebraic method, or we can try using multiple numbers to divide these 3 angles and see which common number will give us this ratio. For example, if we use 10, we'll get 5:6:7. So similarly, we can try to find a common number which will divide all these 3 angles and give us this ratio of 4:5:6. Or there is another simpler way of doing this. We know that they have to be in the ratio of 4:5:6. So write down 4:5:6. Now divide the numbers in the last column with 6 and see which one of them will get divided cleanly by 6 without a remainder and without a decimal point. 70 will not, 75 will not, 6 11s are 66, so that leaves a remainder of 2, so this also will be eliminated. 72 will get cleanly divided by 6 because 6 into 12 is 72. Now we know that 12 can be the common number or the common factor. Therefore, let's multiply 5 with 12 and we get 60. 4 into 12, we get 48. Therefore, we have identified that option 3 is the correct answer. Ragini reaches the station at 2 in the afternoon. She has to take a train to Aligarh. There are 4 trains A, B, C and D scheduled for departure at 17:05, 4:32, 18:30 and 19:15 respectively. Which train must she take so that she spends a minimum amount of time waiting for the train? So obviously she has to take the train which is departing the earliest after she has arrived at the station. Now, if you are not paying attention, the mistake that many students have done here or will do is that they look at this 2 and they think that okay, this train is leaving at 4:32, so which means that this train is leaving 2.5 hours after Ragini has reached the station, therefore this should be the answer, and they select option B. But this is not the correct answer, because if you pay attention, you'll see that Ragini is reaching the station at 2 in the afternoon. So this 2 is in 12-hour timing format, whereas the train departure times are given in the 24-hour time format. Therefore, let us convert this 2 also into 24-hour format. So that will be 14:00 hours. Now, if we look at it, this option B, train B, is leaving at 4:32 next morning. So that is not the correct answer. Therefore, now if we look at it, the earliest train is option A, or train A, which is leaving at 17:05, that is 5:05. So train A is the correct answer here. Rita is a ward member of her area. She wishes to create a community room of the size 12 feet into 16 feet. To lay tiles on the floor, she has 4 options, that is 1.5 into 1.5, 2 feet into 2 feet, 2.5 into 2.5, 3 feet into 3 feet. What size of tile should she buy so that she can lay tiles without cutting? Okay. This question has been given wrongly in the question paper, where it has been mentioned as 11 feet into 16 feet. If it is 11 feet into 15 feet, none of the given options will work. Therefore, this question has been deleted and all the candidates have been given marks for this. But if you come across this question, let us see how to solve this. So solving this is very simple. Right? We know that the size of the room is 12 feet into 16 feet. Now, if suppose instead of the 1.5 into 1.5 feet tile, we had a different size tile. Say we had a tile of 2 feet into 4 feet, or we had a tile of 2 feet into 3 feet. Now, if we were to see which of these tiles can be used to lay the flooring without cutting any tile, so what we have to do is divide the length of the room or the breadth of the room with the dimensions of the tile. For example, I tried dividing 12 with 2, and I know that it will divide without any decimal point, without any remainder. So no cutting required. So which means that if this is okay, then I need to try it with 4 as well. Now 4 has to divide 16. If 4 divides 16 without any decimal point or without any remainder, then it would be perfect. It would work. Now similarly, if I were to try with a tile of 2 feet into 3 feet. Okay? So first I will try to divide the length of the room with 2. I know that it will divide without any remainder, without any decimal point. So 2 will work. Now 3, if I try to divide 16 with 3, it will not work because we will get some decimal point, we'll get some remainder. So it means that this tile might not work in this dimension. But if I reverse it, then 2 will divide 16 properly and 3 will divide 12 properly. So which means that 2 into 3, this size of tile can also be used in this room without actually having to cut any tiles. Right? So that way, check the length of the tile, whether it divides the breadth of the room or the length of the room. If it divides one of the sides, keep it aside and now check the other side and see if it divides the length of the room or the breadth of the room. So which means that each side of the tile should be able to divide at least one side of the room without any remainder or without any decimal point. So now we have seen the example. So let us try it with the options that have been given. Now here it is a lot more simpler because the tiles are squares. So which means that instead of trying to divide with two numbers, we just have to divide with one number for each tile, which is 1.5, 2, 2.5 or 3. So here we know that the room is 12 feet into 16 feet. So if we use 1.5 into 1.5 tile, 1.5 will divide 12 properly, but it will not divide 16 because we will get some remainder or decimal point. Therefore 1.5 into 1.5 feet tile will not work. 2 into 2, when we try to divide with 2, 2 will divide 12 and 2 will also divide 16. Therefore the length of the tile will divide the length of the room and the breadth of the tile will divide the breadth of the room. So it will work. Therefore the correct option has to be 2 into 2 feet. If we try with the other two options, 2.5 into 2.5, 2.5 will not divide 12, will not divide 16 properly without a remainder or without a decimal point. Therefore this can be eliminated. 3 feet into 3 feet. Now 3 feet into 3 feet, 3 will divide 12, but 3 will not divide 16. Right? Because there is 3 here also. So again here also 3 will divide 12, but neither the length nor the breadth of the tile will divide 16 properly without any decimal point or remainder. Therefore 3 into 3 will not work. So this can be eliminated. So we just have one size of the tile which will work for this room and cover it fully without having to cut any tile. That is 2 feet into 2 feet. So the correct answer is option 2. Renu divided her students into groups of 8 each and asked them to record their weights. She further asked the groups to calculate the mean weight of the respective group. Group A, which consists of 8 students, measured their weight and calculated the mean weight as 38.2 kilos. Later they realized that the weight of one of the students was recorded incorrectly. Instead of 25.9, they recorded it as 29.5 kilos. What will be the correct mean for the group? So how was this mean calculated? Well, the mean was calculated by adding the weight of all the 8 students and dividing it by 8. So that's why we get the average, that is 38.2 kilos. So one of the candidates, or one of the students, instead of writing it down as 25.9 kilos, which is the actual weight, they wrote it down as 29.5, which means that they took a higher weight. Therefore, the mean or the average has actually increased, right? And it should be decreased. There are multiple ways of solving this problem. There is also an algebraic method where we take x and we do the calculation, or there are some other methods as well, but we will look at probably one of the most simplest methods. So understand the problem. Here the weight has been taken as 25.9 instead of 29.5. So what is the actual increase? So 29.5 minus 25.9 will give us 3.6. So the total has increased by 3.6, which means that the average has increased by 3.6 divided by 8, because we divided the total by 8. So which means that 3.6 also would have gotten divided by 8. So if we divide 3.6 by 8, we will get 0.45, which means that the average or the mean has been increased by 0.45. So we have to reduce it by 0.45. So 38.2 minus 0.45. So if we do that, we will get 37.75. So the correct answer here is 37.75. So instead of using the algebraic method, just look at this entire problem from a common sense perspective and see what is the mistake that has been done and how that mistake can be corrected. So if you correct the mistake, then you will get the correct answer, and the correct answer is 37.75, which should be the mean or the average of these 8 students. Observe the following pattern and select the next term. So this is a very simple pattern recognition problem. So we know that the last number, right, the result, if you look at it, 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, right? So the next one obviously has to be 1, 2, 3, 4 and 5. So if you look at it, we can eliminate the first one because it says 1, 2, 3, 4, 5, 6. So it has to be 1, 2, 3, 4, 5. So we are left with 3 options. Next, we look at all 8s here. Since all the options have 8, we leave it as it is. And since it is 1, 2, 3, 4 and next it has to be logically 5. So if we look at all the options, 4 eliminate, 4 eliminate, 5. So 5 it matches. So this has to be the correct answer. So if we look at the first number 9, 9, 8, 9, 8, 7, 9, 8, 7, 6. So it has to be 9, 8, 7, 6, 5. So 9, 8, 7, 6, 5. So this is the correct answer. Priyanshu has currency notes of 10 rupees and 20 rupees. She uses 2 notes of 20 and 1 note of 10 rupees to form 50 rupees. How many other combinations are possible to form the same amount using both the currency notes? You can ignore the spatial arrangements of the currency notes. So which means that we have to make this 50 using both 10 rupee notes and 20 rupee notes. So how many combinations are possible? So if we were to try to make 50 rupees using both these notes, it can be 10 plus 10 plus 10 and 20. And if we look at the other options, it can be 10 and 20 and 20. You can try any other combination, but you will not be able to form 50 if you have to use both 10 rupee and 20 rupee notes. Right? So these are the only 2 combinations which are possible. Now, since she has already used this combination, that is where she has used 2 notes of 20 and 1 note of 10, that is 2 notes of 20 and 1 note of 10, she has already used. So how many other options are remaining? There is only 1 option which is remaining. Therefore, the correct answer is there is only 1 other combination left. Following are 4 questions posed by a mathematics teacher. Which of the following is an open-ended question? So now what is an open-ended question? Any question that can have more than 1 correct answer can be an open-ended question. Now the first option says if the sum of 2 numbers is 15 and one of them is 7, what will be the other number? So the answer to this question will be 8, because 15 minus 7 is 8. So there can be only one possible correct answer here. Therefore, this is a close-ended question. If age of Anil is 7 years and his father is 5 times more than Anil's age, what will be the age of the father? So the age of the father will be 7 into 5. Therefore, there can be only one correct answer here. So this is also a close-ended question. If the sum of 2 numbers is 17, what are the numbers? So here it can be 1 plus 16 or 2 plus 15 or 3 plus 14. So there can be more than one correct answer to this question. Therefore, this is an open-ended question. The last one is what would be added to 17 to get 23. So we know that the answer here is 6. There can be only one answer. Therefore, this is also a close-ended question. So among the given options, there is only one open-ended question which can have more than one correct answer, which is option 3. A teacher uses the following riddle in the class while developing the concept of place value. I am less than 5 tens and 4 ones. The objective of the riddle is to do which of the following. Now, what is this 5 tens and 4 ones? 5 tens is 50 and 4 ones is 4. So 54. I am less than 54. So it can be any number which is less than 54. Now let's look at the options. Do a summative assessment. Summative assessment is a way of summarizing the learning of the children. This can be a weekly test or a monthly test or a annual exam. So here we are just asking a riddle. We are not doing any summary assessment or summative assessment. Therefore, this cannot be the correct answer. Break the monotony of the mathematics class. This can be a possible correct answer, but this is not a very strong answer, right? So this also can be eliminated. Ask close-ended questions on place value. Now this is not a close-ended question, because if you are saying that it can be any number less than 54, it can be 53, 52, 51, so it can be any number. Therefore, this is not a close-ended question. Therefore, eliminate. Which leaves us with one option. Reinforce the concept of base 10 and place value. So it's already given that she is trying to develop the concept of place value, right? So the answer is already given in the question. Therefore, option 4 is the correct answer. Which among the following is or are the objective or objectives of teaching shapes at a primary class? To develop visualization skill. This is correct, because when you say the word square, children should be able to visualize what is a square. When you say circle, children should be able to visualize what is a circle. So visualization skill is very, very important to understand geometry. Therefore, this is a correct statement. To memorize the names of geometrical shapes. They have to memorize, or they have to remember at least the names of the basic geometrical shapes. So this also can be correct. To enhance spatial reasoning ability. So if you tell a child there is a square of 2 feet into 2 feet, right? So the child should be able to imagine or spatially reason what a square of 2 feet or 2 feet will look like. So developing spatial reasoning ability or imagination is also very, very important. Therefore, this is also a correct statement. So now all the three statements are correct. But if you look at what has been mentioned in the NEP and the NCF, it says memorization should be avoided. So let us delete statement B. So we are left with A and C, which means that option 2, which is A and C, has to be the correct answer. Which of the following teaching and learning resources in mathematics can be used for visually challenged students? So in some of our other videos, we have already discussed what are geoboards and what is an abacus. I would still recommend that you should Google and look up on what is a geoboard and what is an abacus, because both of these are used for teaching visually challenged students. Now, GeoGebra and graphic calculator are not used for teaching visually challenged students. GeoGebra is actually a software which combines geometry and algebra and calculus. So it's a software which is used for advanced calculations, and it is not used for teaching visually challenged students. So this is incorrect. And a graphic calculator or a graphing calculator is a type of advanced engineering calculator which displays graphs, right? So this is also not used for teaching visually challenged students. Therefore, the correct answer here is A and C. So A and C is the correct answer. While teaching geometrical shapes, a teacher thinks of planning a trip to historical places. It reflects which of the following? Now, the first statement is field trips have been recommended by CBSE, so they must be done. This might be a correct statement, but this is not appropriate here, right? So we'll eliminate this. It is a good break from routine mathematics class and an opportunity to visit historical places. This might also be a reason, but this is also not a strong answer or a strong reason here, right? And the last one, teacher has completed most of the syllabus well in time and now needs to provide leisure. This can also be partially correct, but this again is not a very strong answer. So if you look at all the four statements, multiple statements can probably be correct, or can be argued that this might be one of the valid reasons. However, you have to select the strongest reason from among the choices. Statement 3 says, shapes are an integral part of any architecture and such trips encourage mathematics beyond classroom. So if you go to a historical place like the Taj Mahal, you can see that circles and rectangles and triangles are part of the design and the construction of historical monuments like the Taj Mahal. Therefore, when you visit a historical place, students can look at how mathematics actually occurs or geometry actually is used in real world, right? Therefore, they are encouraged to think about mathematics beyond the classroom in the real world. Therefore, statement 3 is the best answer among the given options. A primary class mathematics teacher poses the following question to his students. Reena and Shama went to a shop to buy a bag. There were many bags with different price tags. They got confused by looking at so many price tags. Can you help them by arranging the price tags either in ascending or descending order? So the teacher has given some data and the students have an option of either arranging them in ascending or descending order, right? So we have to see which of the following statements is correct. Let's start with the last one. The last one says the teacher should avoid bringing contextual questions into the classroom. This is completely incorrect because if you look at what the NEP and the NCF say, they say that all the teaching and learning that happens in the classroom must be contextual to the extent that is possible. That is, students should be able to relate what they are learning in the classroom to real world experiences. So that is contextual. If you say should avoid bringing contextual questions, this is completely incorrect. Next, it is not a mathematical question as it does not involve basic operations on numbers. Now, this might not involve very basic operations like addition or subtraction, but even arranging these numbers or comparing these numbers is also a mathematical operation. Therefore, it is a mathematical question. If you say it is not, then this statement is incorrect. Next, only the concepts of ascending and descending order can be strengthened using this question. If it was just about teaching ascending and descending, teacher could have given some very simpler examples like 3, 1, 4, 2 and say arrange them in ascending or arrange them in descending order. But the teacher has given more data than just mere numbers. So this goes beyond ascending and descending, right? So this question is not just dealing with ascending or descending order. Option 2 says the teacher can use this question to go beyond comparison of numbers and introduce the concept of data handling and sorting of data. Now what the teacher has done here is given some data. This data can be arranged in ascending or descending order so that the data can be converted into useful information, right? Therefore, this question is going beyond just comparing numbers. It is teaching the concepts of data handling and sorting of data. Therefore, option 2 is correct. According to the National Curriculum Framework 2005, which of the following represents the vision of mathematical classroom? Now, even if you have not read what is written in the NCF 2005, this is a very easy question because the first statement says students memorizing the formulae. Now, NCF and NEP, both of them say that memorizing should be avoided, right? Therefore, this is incorrect. Next, teacher is the only narrator in the classroom, which means the teacher is standing in one side and giving a lecture and all the students are just listening or hearing the lecture. So that is a teacher-centric classroom and that cannot be a progressive classroom. Therefore, that is not recommended by the NCF or the NEP. Therefore, this also can be eliminated. Next, students copying solved examples from a textbook. If they're just copying solved examples from a textbook, how do you know that they have actually understood what they are copying, right? So this is as good as just memorizing something without understanding. Therefore, this is incorrect because NCF does not say this at all. It says that just copying or memorizing should be completely avoided. Now the last one says children posing and solving meaningful problems in the classroom. Now this is where contextual problems come into picture because whatever is being taught in the classroom, the theory, the children should be able to relate to it in a real world scenario. They should be able to use real world examples to understand what is being taught in the classroom. Therefore, statement 4 is what the NCF recommends as the vision of a mathematical classroom. Which of the following statements is true for anecdotal records as an assessment tool in mathematics? If you know what are anecdotal records, you can easily identify the correct answer. Even if you don't know, the simplest way to remember this is anecdote means a story. It is a narration, right? It is a detailed description of what happened, how it happened, who are all there, what did the teacher do, what did the student do, right? So anecdote is a story. So remember that. Now, if you look at all the options, see which of the options talks about a long form description or a detailed description of what happened in the classroom, how it happened, and provides a long story. Right? So the last option says it includes a written description of the child's progress on a day-to-day basis. So this is a daily story, and it provides observational narrative records. So it is not short form. It is a long, extensive, detailed narration of what happened in the classroom with the student. What did the teacher do? What was being done? So it provides a complete picture. Right? So option 4 is an anecdotal record. It is not just about recording the absence or presence of a particular skill. It is not just about recording or judging the quality of a child's work or comparing it against a specified criteria. It is not just about some project or field work. An anecdotal record can include all of these and go beyond that. Therefore, option 4 is talking about anecdotal records. A class 3 teacher introduces multiplication in her class using repeated addition and rectangular arrays. She is doing which of the following? Now, what the teacher is doing is using repeated addition. For example, 2 plus 2 plus 2 plus 2. And she's saying if it is being added 4 times, it means that 2 into 4, that is equal to 8. This also is equal to 8. So she's using the concept of repeated addition to teach about how multiplication works. She's also using rectangular arrays. It can be something like this: 0 into 0 is 0, 0 into 1 is 0. So it will all be zeros here. Then it will be 0, 1, 2, 3, 4, 5. And then it will be 0, 2, 4, 6, 8, 10. So you can use arrays or tables like this to teach about multiplication. So what is the teacher doing here? Now, is she just finding leisure time for herself by keeping the students engaged in something? Absolutely not. This is incorrect. Next, is she wasting a lot of time and focusing on useless things, and she should be focusing on teaching formal algorithm only? Now this is also incorrect because she is not wasting time, right? And is she actually teaching multiple formal algorithms of multiplication? No, she is using informal methods, simple methods that students can understand, right? So this is also incorrect. So option 1 says she is introducing multiplication through informal strategies by utilizing the previous knowledge and experiences of the students. That is, if students have previously learned addition, so she is teaching how addition is connected with multiplication. Therefore, she is using previous knowledge and introducing multiplication through informal or simple strategies. Therefore, option 1 is correct. A child is counting the number of balls by putting a finger on the balls one by one and saying number names in order. She has counted some balls twice. Which pre-number concept is yet to be strengthened in the child? Very simple question. Here we are talking about one-to-one correspondence, because what the child is doing is putting a finger on the balls and saying the numbers in order. So she has to say one number for each ball. For example, 1, 2, 3, 4, 5, 6. So there is one-to-one correspondence between the object and the number. So what the child is doing here is she is counting some of the balls twice. That is, she is saying 1, 2, 3, 4, 5, 6, 7, 8. So she is arriving at the wrong count because she is not doing this one-to-one correspondence properly. So that has to be strengthened in the child. So option 1 is correct. Misconceptions in mathematics can be removed by which of the following methods? Now, misconceptions are misunderstandings or doubts that the students may have. So how can you remove them or solve them? Well, if you give them some examples, after you have taught them the theory in the classroom, if you give them lots of examples and some non-examples as well, they'll be able to understand the theory that you are trying to teach them. So you can keep the children engaged with plenty of examples and non-examples, and through this, you can clear their misconceptions or doubts. Therefore, statement 1 is correct. If you look at the other statements, framing similar questions and repeating them many times. If they have a fundamental conceptual doubt, by framing similar questions and by just repeating them, you are making them repeat the same error again and again, right? So this is not going to help them much. Lot of practice and drill questions. Again, if they have not understood the basic concepts, by giving them lot of practice, they're just going to keep repeating the same mistake. They might memorize the questions, or memorize the answers as well, but they have not understood the process, understood the concept. Therefore, a lot of practice and drill of questions will not help if they have not understood the concepts. Then demonstrating the algorithm again. You have used a particular step or you have used a particular process to solve a problem. So if you keep demonstrating the same thing again and again, if children have not understood the concepts, then repeated demonstration is not also going to help them. Therefore, all these three can be discarded. So only by giving enough examples, you can clear the misconceptions or doubts of the children. Miss Romi in her mathematics class asks her students to create appropriate situations for the following computations. Which of the following statements is correct about the pedagogy used by Miss Romi? So now, if you look at the statements, 10 plus 2, 10 into 2, 10 minus 3, 10 divided by 2. So Miss Romi is not asking her students to solve these. She is asking them to create appropriate situations for the following computations. For example, I have 10 apples and somebody gives me 2 apples. So I will have 12 apples. Or I have 10 chocolates. I need to divide it between 2 classmates. So I divide it by 2 and each classmate gets 5. So she's asking them to create situations for these statements. So let's look at the answer choices. The first one says she is testing the problem solving skills of students by giving mixed set of problems. Now she is not asking them to solve these problems, right? So this is incorrect. Next, she is testing the language proficiency of the skills. This is also incorrect because she is not testing the language or she is not testing how well they can write a story. She is trying to see if they can use these mathematical statements and create a situation for that. So she is not testing their language, and she is trying to help students to develop mathematical statements and problem solving skills. This is a correct answer because she is making sure that children understand what these mathematical statements are and how they relate to real world examples. So she is making them create appropriate situations or examples for this. Therefore, she is helping them with mathematical statements and also problem solving skills in a real world scenario. Therefore, statement 3 is correct. The last one, she is trying to maintain discipline by giving some tasks to the students. No, she is trying to teach mathematics. She is not just giving some random tasks to the students to keep them busy, right? So this is also incorrect. So option 3 is the answer here. Which of the following statements are indicative of the higher aims of teaching mathematics? Now, when you read all the 4 statements, you can argue that almost all the 4 statements are correct to some extent, right? But in cases like this, you'll have to identify the 2 best or the 2 strongest statements, and those will be the correct answer. For example, the first one says, mathematics education should turn out employable adults who contribute to economic and social development. This is a correct statement because you want people who will contribute to the economic and social development of the country, and you want mathematics education to make them employable. However, if you look at it from the concept of basic fundamental education, the reason you are teaching mathematics is not for employment. Therefore, we can remove this statement. The statement is correct, but in this context, in this question, it is not the best statement. Therefore, if we remove A, we can remove option 1 because it has A in it. Next, mathematics education should develop the child's inner resources like abstract thinking, drawing logical conclusions, etc. So this is a correct statement because you don't want to just teach mathematics to children. You want to make sure that the mathematics is used for them in abstract thinking and logical conclusions or logical thinking. Therefore, B is correct. So if B is correct, we can see that option 2 and option 4, which have B in it, right? Both of these can be the correct answer, which means that we can eliminate option 3. Next, children should see mathematics as a way of life, like communicating, discussing, or developing attitude for problem solving. This is also absolutely correct because children should not see mathematics as a subject. They just need to study and clear the exam and be done with it, right? That is not the objective. Children should see maths as a way of life, just like they learn communication or discussion or they develop an attitude towards problem solving. So mathematics should go just beyond mere subject or mere theory. Therefore, C is correct. So if B and C are correct, then B and C, that is option 2, has to be correct. And the last one, mathematics education should focus on factual knowledge and procedural fluency. Now, mathematics is not just about facts and getting the correct answer or getting the correct procedure, right? So mathematics is not about theory. Therefore, the last option can also be eliminated. So which means that the last option with D can be eliminated, which leaves us with only option 2 as the correct answer. According to Newman, there are 5 levels to be undertaken before a student is able to solve a word problem. They are listed below in a random order. Which of the following represents the correct order of these levels? So what is a word problem? A word problem can be something like this. Say Ravi has 2 apples. He buys 2 more apples. How many apples does he have now? So what is the first step in solving this word problem? So if you look at all the options, the first step obviously has to be that the student must be able to read the question, right? If I don't know the language, if I'm not able to read the question, then there is no point. So first step is that the student must be able to read the question. So B has to be first. So which means that the answer can be 1, 2 or 4. So 3 can be eliminated because it starts with A. Next, comprehend what the task is asking. That is, by reading this word problem, the student has to be able to identify what is being asked here, right? What is this problem trying to tell me, or what is this problem asking me to do, right? So comprehend what the task is asking. So here we are asking how many apples does he have now, and we are giving some information on how many apples he first had and how many he bought. So the task here is to see how many apples he has now. So the student must be able to comprehend what the task is asking. So A has to come next. So which means that option 2 can be eliminated because it has D here or D here. So which means that option 1 or option 4 can be the correct answers. Next, he has to translate the problems into mathematical demands. Now when I read this problem, and after reading this problem, I say Ravi has 2 apples and he buys 2 more apples. So how many apples does he have now? So which means that the student needs to translate the word problem into a mathematical statement or a mathematical demand. So D has to come next. So now if you look at it, here there is C, which means that option 1 is incomplete or incorrect. Here there is D. So since we know that D has to come third, this has to be the correct answer. So next let us see C and D. C says undertake the necessary mathematical operations, which is true because after I have translated the problem into a mathematical statement, I need to do the necessary mathematical operation. That is, I need to be able to do 2 plus 2 and then I get 4. So which means that I have to then represent the answer in a meaningful construct. That is 2 plus 2 is equal to 4. So this is a meaningful construct which solves this problem, this word problem. Therefore, the last option B, A, D, C, E is the correct order of these steps. Which of the following is not desirable for the professional development of mathematics teachers? So if you look at all the 4 statements, the first one says attending workshops and seminars on mathematics. This definitely is very useful because when you attend workshops and seminars, then you get to understand what's happening in the wider world, what is the latest thing in the teaching of mathematics. So this is definitely useful. Developing teaching and learning resources. If the teacher is actively working on creating teaching and learning resources, then definitely the teacher is able to practice mathematics and also understand the creation of teaching and learning resources. Therefore, this is also very useful. And the last one, participating in faculty development programs or teacher training programs. This is also very, very useful. Now, statement 3 says minimum interaction with other mathematics teachers working in the same school or in neighborhood schools. There is a saying in Hindi, Kume ka mendak. So if this teacher has minimum interaction with other teachers and other teachers in other schools, so which means that this person knows only about what he is doing and not anything about what other teachers are doing or what is happening in the wider neighborhood. Therefore, minimum interaction is definitely not desirable for the professional development of mathematics teachers or any teachers. Therefore, this is the answer. And with that, we have solved the 30 questions in this question paper. I will see you again in the next video where we will solve 30 more questions from another question paper. If you have any questions or if you have any feedback, then please post them in the comment section below. And the rest, you know what to do. So I will see you again shortly in the next video. Till then, take care, stay safe.